Hello, everyone. We'll just wait a few moments for more people to join the webinar, but for the time being, sit tight and we'll just wait until about 3 minutes past. Thank you. Okay, I think we'll get started. So, hi everyone. Thank you for joining us today. My name is Jess Colbush. I'm your host and moderator for today, and I'm part of the ECOP program's training and mentoring task team. For those recently becoming familiar with the Early Career Ocean Professionals Network, it's a program at the heart of the UN Decade for Ocean Science for Sustainable Development and was endorsed by the UN Ocean Decade as a program in 2021. Our mission is to elevate and strengthen the diverse perspectives of new generations of ocean professionals through a collective voice, ensuring that knowledge is transferred between experienced and early career ocean professionals to promote sustainability for the ocean we want. As part of the knowledge we want to share among future professionals and professionals currently, we've developed a series of webinars that aim to train and inform this community of ocean lovers. And today we have an exciting and super interesting webinar. This episode number 24 is dedicated to our capability underwater, specifically robotics and changes in the workforce. Our speaker today is Kwan. Kwan is the founder and CEO of Deepwave Robotics, a company developing versatile general purpose submersibles to revolutionize underwater operations and address critical labour shortages in marine environments. He will present on the current and future state of the workforce amid rapid advancements in AI and robotics, particularly their transformative impact on ocean-related operations. We will learn how an ageing workforce and hazardous diving environments are driving the shift towards automation, with generative AI closing the intelligence gap to enable smarter, fully autonomous underwater systems. I would like to remind the audience that you can write your questions or comments in either the Q&A section of Zoom or in the chat as well. There are polls throughout the webinar as we'd like to get to know you and your experience and background. And so we'll be able to see those results and engage a little bit. Thank you to all the participants. I will hand you over to Ho Kwan. But if there are any questions or queries, please place them in the chat. Thank you.
Thank you, Jessica. So let's get started. Let me share the screen right now. Okay. Can everyone see a screen?
Screen looks good.
Okay. So basically, extending capability underwater, so robotics and workforces. So it's basically an introductory webinar on robotics and marine operation in general, like for marine science. It's gonna be introductory, so don't worry. Nothing too technical today. It's gonna be introducing the landscape of robotics and how it's really shifted like in the past decades, and basically what's next for underwater operations and how we interact with oceans. So let's get started. Mm, Okay. Can you can you post the poll, please? So may I know what's your field of research and where are you from?
Launch. I've just launched that poll now. Or did you
Okay.
want me to pause this poll?
Yeah. I think that's good. To host.
So everyone has a few moments to answer the poll.
Yep.
And let us know where you're joining from. Are you an early career ocean professional? And also, what is your field of work?
Okay, very interesting. View from Europe. Okay, marine biology.
We'll give everyone a few more seconds. Okay, we'll end the poll now and share those results with everyone.
Okay. Quite a lot of people from different backgrounds. It's interesting. Oceanography, marine biology. Oh, okay.
And
Interesting.
also a few not ecops, so welcome.
Okay.
All right.
So, okay. So let me introduce myself a little bit more in depth. So I'm the founder and CEO of Deepwave Robotics. I'm building a general purpose submersible to tackle on high dexterity job. But then I myself is a robotics engineer that has 7 years of experience. I've worked on robotic arms algorithms, teleoperations. You can see the guy with a crazy hair is controlling the robotic arm there. And then I'm also a control engineer when I was in an outboard company, electric outboard company. So I was responsible for modeling the dynamic and kinematic model of a boat, basically, and trying to make it move laterally, forward, diagonally, and holding onto a position on a strong current. So that's basically my background on marine robotics. So with this webinar, hopefully I can make you guys learn a few things. So the first thing is that the analysis of the underwater workforces, like from my point of view as a roboticist. So how many ways we could interact with the underwater world. And secondly, what has happened in the robotics scene in the past decades, and what's the next step for the ocean operations? Okay, so is it true that we know more about the Mars than the bottom of our oceans? I would say no, according to my research. So let me explain why. We may have a lot of high resolution of mass mapping on the surface, but then we also get a nice map by in a past year. There is a model that is published on the seabed 2030. It's basically utilizing some new technology on satellites with other implementary sonar mapping with high-end research ship and all those. And in combination, it gets pretty accurate maps of the seabed, actually. So some of you from the ocean geography expertise may know how it works. So basically, the water is following gravity field and it's latching on to the peaks and valleys of the ocean. So when we basically map the water surface, we get a pretty accurate representation of our seabeds, basically. So that's how we get good enough of seabed map from there. And 27% of the maps are actually mapped in high resolution of like a 1 meter accuracy, utilizing advanced sonar imaging technology. So which is very impressive too. Um, but then when we look into how much we actually visit into the ocean, it's actually very little. So when we look into the graph here, so basically this is how little we have seen a visual coverage estimation of the deep sea floor. It's actually a published paper on like analyzing how much we have visit our seabeds. So it would have like demographic of like how frequent we visit and where we have visits and all sort of data. So if you're interested, you can always visit that paper. So when we look into the graph they have plotted, it's basically the colored areas are the areas that we have visited actually visually explored. So it's from deep blue to light yellow. And its deployment is from 0 to 2.5K. So when it is the brightest, it's the most frequently visited areas. So we can see there is quite a few dots that are pretty bright, that is most frequently visits. But then overall, it's very scarce and it's still a lot of areas that hasn't been explored. So it's equivalent to 0.001% of the ocean's area that is being explored. And when we look deeper into the data, the depth of 200 to 1,000 meters of depth, it's actually the most visited because for obvious reasons, it's more accessible, it's easier to get research done on. But then when we look into the actual oceans area, 4,000 to 6,000 meters of depth actually consists of like 40% of the oceans area, which we have only explored it in 5% of our visits. So we still haven't really visited that much places in our oceans. But I mean, you may ask, like, Kwan, is it necessary for to really cover the whole area of oceans and all those things? It's in my point of view, it's not necessary because like there's so much more than just mapping the seafloor. There's biodiversity. We may want to look into the chemistry composition of the ocean. It's different from 1,000 meters of depth comparing to like 6,000 meters of depth. And then there's a current data. There's so much more we can dig deeper into. And some of the samples or the places that we visit can easily map the whole model of the oceans. But then it's also meanings that like we don't actually discover more of the new species underwater. We don't get to visit more the really detailed features under the sea, or like under the valleys of like the seabeds, seamount, and all those of things. There's active um, volcanoes underwater, and all sort of things are not fully explored yet. So if we have really visited only 0.001% of our oceans, like I think we can actually trying to think of something to speed up the process of it. So, and then to the next topic, I'm gonna be presenting to you the workforce report that it's drafted by the World Economics Forum. So it's basically in-depth reports for future of jobs, like how workforce has shifted, and it's also projected from 2025 to 2030, and how the workforce are changing like over time. So let me introduce you to a concept here, or let me explain a little bit like what's inside the report first. So it's basically analyzing globally how workforce has shifted, and also having uh, in-depth report for each individual countries on the earth, like over 200 countries are surveyed, and there's questionnaires to circulated to like the employees, employers, and asking about like how the work has shifted, like the skill set they need, and what are the occupations most wanted, and etc. etc. So let's take. So I've concluded like around 3 points in this report. So before I get into the report, let me introduce you to like the concept of manual, augmented, and automated workforce. So it's pretty self-explanatory that manual workforces is something very hands-on. So if we're taking into like driving automations as an examples, we are just normally, if we are normally driving a car, it's manual type of like work. We drive manually, and then for the augmented side of the work is that there is some sort of assistance to your work. So for example, there's cruise control that hold on to like the pedal, so that it's hold on to a throttle. You don't have to hold it manually with your feet. Basically, it won't get tiring. And then it holds on to like the wheel, so that you don't have to constantly fight the wheel. So that's basically the augmented side of like the features. And automated is essentially you don't really need to drive. You just press a button prompted with like excuse me with like location, and then it would drive automatically to the locations, and it would take care of all those object avoidance and all those. So if we, and those apply to like the office work, like not only to like the blue collar jobs, also to the white collar jobs. So if we were a auditor, like we will manually input data into Excel sheets. So like it's manual. But then if you start to implement some OCR tools that you scan for receipt and all those, and then inputting those data into the spreadsheets, then you're using a semi-auto function. So it's augmented one. And automation is basically you just give it a prompt and it will take care of the rest of the actions. So let's make the definition more clear from there. So looking into how the workforce has shifted and it's projected into like 2030, we can see there is like 40% decline into a pure human workforce. And then there is around 12% of the increase into the pure technology type of like the workforce. So we can see,
Sorry to interrupt, Ho Kwan. Can
like,
I think the slides might not be advancing properly. Would you be able to stop sharing and then just restart to share the screen again?
oh, okay, sure.
Is everyone able to see those slides now? If people can reply in the chat.
Yeah, I'm currently on like the pure human workforce, slowly declining slides.
I'm just waiting to hear some responses from people.
Yep, me too. But is it okay from your side? Like, are you?
I can't see it, but I think, okay,
Oh, okay.
they just see a black screen.
Oh, they see
Okay,
it. Okay.
okay, interesting. Perhaps, my apologies. I thought it was only my computer, so I didn't change that. Do you want to maybe log out and log back in again, Ho Kwan?
Sure, sure, sure. Give me a sec. Okay.
One moment, everyone. We'll be back soon. But if you have any questions in the meantime for Ho Kwan, please write them in the chat. Please write them in the chat, and we can get to them as soon as he gets back. Um, apologies for the changes in the technology. I thought it had shown up on everyone's screen. Hi, Ho Kwan. Did you want to try and reshare your screen up to the point, maybe a few slides before?
Sure. Is it showing properly?
No, for me, it's still a black screen,
Oh.
which is interesting because initially it was correct.
Yeah, 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 I saw. Give me a sec.
Alternatively, you can send me your slides. No, that still hasn't worked.
Oh, wow. Sure. Wow.
Kwan, I think you might be frozen now. Again, apologies everybody for this. Hopefully we'll get back and running soon. Kwan, are you there? Are you able to hear me?
Uh, yep, I can hear you. Let me. How should I? Or let me try
Um,
one more time and how to share the screen, and let me share the slides also to you. Give me.
yeah.
Uh, is it showing properly?
Yes, that's up now. Yep.
And is it out now?
Yep. It's on the PowerPoint now.
Oh, it's on the PowerPoint. Okay.
Yep.
So do you see the PowerPoint now?
Yes.
Oh, okay. That's interesting. Okay. So
So, so
where was I?
I think we were at this slide. I think if you can make it full screen, that'd be good.
Okay. So it's all okay, right? Okay.
It's all okay. Yep.
All right. Right. So back to the PowerPoint, the presentation. So pure human workforces. There is like 14% decline in pure human workforce. And then there is a 12% increase in pure technology ones. So we can see it's predicted to shift towards mostly to the automations. It's interesting because like we thought the technology would gradually advance, so from augmented and gradually change into automations, but then it's suggesting like only 3% has increased in the augmented part of the workforce, considering how much it has changed like in the pure human workforce. So it's this graph also shows like the dotted square. It's the discrepancy between the pure human workforce now and comparing to like the projected 2031. So it's basically 81% is being replaced by automation instead of the augmented one. And some industry are actually more prominent in this situation. So when we look into oil and gas, 140 around 150% of like the changes, which is exclude that there is purely automations that is being implemented in so that it's also replacing part of the augmented side of the workforces. So it's very interesting that oil and gas has that transformation
Kwan,
already.
your audio has stopped. Perhaps put yourself off and on mute.
Hello, hello,
There we go.
hello.
That's good. Yep, working now.
Okay. So where was I?
Oh, it was only for one moment.
Oh, okay, okay. I see. Right. So it's in agriculture and oil and gas, they adopt a lot of automations that even some of the automations are replacing the augmented um, workforces. So it's very interesting from there, from this point of view. And we actually look into like the the changes in each individual industry or categories of work. So there is AI, big data, network, creative thinking, programming, marketing, etc., etc. So there's like category of work. So this graph is showing how it is decreased over time or increased over time. So basically, if we just look into the manual dexterity, precision as like the the character we have like as a workforce, like it's less wanted. It's a lot of people are actually decreasing the use of it. There's no requirement into like we getting our hands dirty, require us to do high job that is like high dexterity high in endurance, in precisions. We are mostly leaning towards AI, big data, etc., etc. So there's a change in the skill set of workforces also. And for the business transformations, they divide also into categories in what are the occupations are there, and they can see there is a decrease, 20% decrease in the factory workers. So we can see the blue collar jobs, the high labor intensive work are slowly decreasing in demand, or even in or supply, basically. And one of the factor could be because of the warehouse or factories are essentially implementing more and more automations into it. So there's a clip of the. So you can see the work that they're automating is not merely something that you usually see in the factories, that it's on a production line, there's a conveyor belt that would push thing on and off, or sort of thing. It's actually very intelligently sorting out the cargoes within the Amazon cargo, the warehouse,
Hi,
dividing up
Kwan.
packages.
Apologies. The presentation is frozen again.
Huh? Then
Perhaps
okay,
skip to after the video. It might be more. It might be something to do with the video.
okay. Is it sharing properly?
Yeah, it says the aging population slide.
Yep.
Perfect.
Okay. So
You can
right.
explain the video, even though we can't see it.
But yeah, basically, it's that we can see that kind of work are usually being sorted by humans, but then nowadays it can be also sorted with robots, implementing a lot of different technologies with optics and robotics, and other sort of things. So it could be one of the factor into why it's the automations are replacing human more instead of like using human in conjunction with the technologies. That kind of workforce is not as popular. Mm. And then the other factor is that, like in this survey, it's finding there is an aging populations that also contributes to the problem that we may not have as much labor intensive worker that is available in the market. So there is a lot of different factors that is affecting how the workforces is being shifted. So in one side, it's people are less willing, the willingness into going into like the blue collar jobs is decreased, and then also the automation is more, it's demanded, so that it's all implementing into different places. So we can see how it is shifted overall for the workforce. And how is it important to our oceans? Like, I mean, Ho Kwan, we are just a bunch of, we are ocean researcher. Like, why would we care about this? We're just studying the, the ocean currents, how the marine ocean geography, the features, and all those of biodiversity. Why should we care about the workforces, specifically underwater? So I would say because it's actually how we interact with the oceans. In my point of view, there there are ways that to interact with the ocean directly right now. But then we can also look into what has happened on the earth and overall globally and trying to catch up with the trends. So there's actually a lot of initiatives that trying to automate a lot of stuff um, around the world and deploying a lot more UAVs, which is automatic underwater vehicles, is using a lot more automation than ever. So we can try to keep up with the trends. So let me look into what we have for underwater workforces for now.
So Hoquan, the slides are not sharing at all now. I think you exited the slides. So if you bring them up again.
Exceeded the slides, or
So it says you're not sharing.
oh yeah, what happened? There's so much more. But anyways, it's okay now. Yeah.
Yes, it's okay now.
Okay. Okay. So first thing is a diver. It's the most direct way to interact with the ocean. We dive directly into the oceans and actually pick up the muds and all those stuff. It's still in demand because not only you may want to do samplings underwater for other industry, offshore industry, other underwater construction company may use commercial divers for maintenance work, inspections, repairs, for oil rigs, cables, and pipelines, etc., or even building new data centers. Is it?
Yes, it stopped sharing again.
What is? How can I stop this? It's
Yeah,
sharing now, right?
it's on the divers are still in demand page. A now half working environment. Yep.
Why is this happening? But let's finish this.
It's
So
okay. Yeah.
and then it is indeed working in a harsh environment, whereas it's low in visibility, especially when you are near the construction sites. It's easy to get all those mud in the air, so you cannot really see. And for some of the commercial divers, if they go deeper than 500 meters, they may need a compressed chamber to slowly descend them. So it's time consuming and they will have decompression sickness. So it gets into a point that when we look into the statistics, 77% of the divers often quit after the 5 years of their experience. And some of them getting out of the profession with hearing loss, bone damage due to the barrel traumas. And not to mention, it's a high risk job that people start to decline in the interest in getting into commercial divers. Uh, and then, so if we look into like, because ocean is basically not inhabitable for humans, yeah. So we would try to build stuff around it so that we can get access to ocean. So we may have manned vehicle that we could sit in drone types of things, but then we are inside a dome of glass with windows so that we can actually see what's outside. So that's how we were first exploring the oceans. They will man the vehicle, and often they are built with incredible depth ratings, so it could go under 6,000 meters of depth. And because they have a lot of windows, you're in the environment, it has great situational awareness. but also it's a very expensive type of explorations, and also not as easy to scale, at least. So there is some sort of risk also in going into this kind of vehicles, because essentially there's still human involved in the vehicles. And then the drones or RV that we usually use, it's starting to rise as like tools for people to do inspections, surveying, and all those are, it's very useful. It's already saving a lot of lives and times into operations, simply because they can just survey the environment, where exactly is the problem is, and then look, because the problem is located, so the divers can directly dive into, let's say, to a place for repairing subsea infrastructures, cleaning barnacles, or even samplings for muds and water samples and all those of different kind of works. And then, and also automated type is also deployed for scanning sea maps. And basically it's just like some of the submarines, it will go back onto the water surface from time to time, so that they can present the work, send them over the internet to back to the centers or research center and other places. But when I look into the ROV categories, there's also a lot of attachment that can be attached onto the ROV. That makes me thinking, actually, our ROV are required to do some sort of minimal work, except for like other inspection type of things. You can see fishing nets, claws, and all those for picking up stuff. So it's really interesting that ROV would would need other capabilities beyond inspections also. So Jessica, can you post the poll? So have anyone ever used an robot or ROV in their research?
I've launched that poll now.
Okay. So because like as a roboticist, I'm interested in how often you guys use and if you actually encounter one, because some of them may work in the lab for the whole time, or it's just interesting to me.
Okay, so I'll now share the results if people want one more second to answer. Okay. So can everyone see those results?
Okay, I see. Oh, quite interesting. There's quite a lot of people actually use a robot or ROVs in their research.
Yeah.
Perhaps for ocean geographer may need ROV to actually visit the place, or even look into like new species and stuff. So
Yeah.
it's very common for people to use ROV, I guess. And some of the RV can actually do work. It's very common for you guys. It's not something that is very alienated. It's basically a drone with two robotics arm. There's a two finger grippers that you can pick up a lot of different kind of things, samples, water samples, new rocks, corals, And even some of them are attached with water jet guns so that you can clean the barnacles on the structure of subsea oil rigs and all those chains that is attached to the to structures. A lot of different things that can be used for on with this world class ROV that we refer to as like a world class ROV. And when I look into the world class ROV, I mean, it's already doing a lot of different things. You can do underwater welding for repairing stuff, fastening screws, and it's very essential to our workflow. Under 1,000 meters of depth, it's very crucial for those kind of work because human are essentially cannot go beyond that depths. But then when I look into the consoles, there's a
Sorry,
lot of
sorry,
screens.
Hokwan. We've lost the screen again. Perhaps if you turn off your camera, it might help with the sharing of the screen.
Okay.
And maybe yeah, there we go. It's come up now.
Oh wow. Okay.
Yeah, it might be a bandwidth issue.
Yeah, I guess. Yeah, I guess so. Oh, okay. But the screen is working properly. Yeah.
The screen is working properly now. Yeah, it just came back
Okay.
on.
Okay. 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 And then I can see there's a lot of screen into when we work with world class ROV. There's 3 to 4 cameras that look into different angles of things to give the pilots the situation awareness of like what's surrounding the RVs. And there are also sonar image, altitude, headings, and all those data, pressures, probably temperature, so that the pilots can wield the RV properly. And how they are controlling it right now is that one is controlling the chassis and the other one is controlling a little robotic arms with encoders. So it would move the arm, it would mimic exactly how the little arm moves. So in that way, you can control the robots. So with that kind of technology, it's giving us a lot of it contributes a lot to like our ocean operation work. And also, RV pilot is a very demanding profession, as in you need to learn a lot of different stuff. For example, hydraulics, electricals, electronics, fiber optics, a lot of different things surrounding the ROV in order to properly control an RV. Because sometimes you may want to maintain the RV yourself, doing some checkups before the one dive or one descent. So it's very common for RV divers to learn a lot about the mechanics, the electronics of the robots also. And then, but when I look into those category, I feel like there's something missing. Is that there is none of the robots. I would just categorize them as robots. Are built exactly as if to replace humans. A lot of the sentiments is still revolving around RVs and divers are basically companions to each others. They mix a good pairs, but then none are really trying to brand themselves as robots that trying to do the work that human can actually do. And I do feel like it is actually quite a true phenomenon, as in the dexterity is in fact cannot really match with the humans for the robots right now. especially there's still a lot of critical jobs that requires human to do it. And sometimes the ROVs, because they were stuck in certain places, they would need humans as a last resort to really recover them. So, and then after looking into the underwater robotics scene, so what has happened in the past decades in robotics scenes, like on the ground? So the first thing is that the electrifications really change up a lot of things. So battery used to be something that is low in power density, it stores so little powers, and motors were not powerful comparing to hydraulics. If we want some high power output application, we would opt for hydraulics. But then it's no longer the and then because manufacturing are more accessible, a lot of drivetrains, how they manufacture has improved. So it's all those different factors have really improved uh, how we can electrify uh, electronics or robots or other vehicles. And this brings quite a lot of benefits to our new products. So because the electrification is
So,
more,
sorry, Ho Kwan, I think it's still on the ROV pilot is a demanding profession slide. Were you on that slide? Oh,
no.
okay.
Is
Now
it?
it's got no. It's work now. Yeah.
Okay.
So if you
I
go
see.
forward a couple of slides.
So I was,
Yeah. Cool. Perfect. Electrification.
yeah, electrification. So basically,
Perfect.
um, lithium-ion battery has improved, drivetrain has improved. So for us, we can have smaller products. We can have improved performance of the robots. So for example, the Boston Dynamics robots, it used to be bulky, 200 kilograms. It's a very heavy robot, but then now we can go into a territories that is close to human-sized robots for the new generation of Atlas, and even it could do 360 turn on by the waist and head, and also it's like it has improved a lot for the performance. And some of the robots that used to belong in factories now becomes like a STEM kits for people in households. The robotic arm are manufactured as like a small kits to do, let's say, some STEM learning, small automations, and all those. It's not only the manufacturing side of it is more accessible because the robotics all knowledge also has improved, so everyone can make great products with small form factors. And the biggest thing is probably AI. But before going into AI, I'll explain what's silicon intelligence and human intelligence. So silicon intelligence, as in like the chips that we have on computer or in a calculator, they can store highs, ones, and zero very well, so that from there it can make very accurate calculations. It's digital, it has high repetibility, but then we're as opposing to humans intelligence that is low in power consumptions, we are basically running in 20 watts comparing to our typical computer is 200 watts, uh, sorry, 400 watts on average. It's very low in power consumptions, but then as a human also we can plan, we can reason, we can do abstract thinking. We can basically imagine something out of nowhere and execute it. So that's the strength of a human and silicon intelligence, respectively. But generative AI really closing the gap between the two, because usually when we're trying to implement some sort of planning algorithms, not only in as we plan how to execute some work, and also a very low-level instruction, for example, path planning on AUVs, how we from point one going to point two to point three, how they execute it, and also how they can intelligently avoid obstacles. It was a very challenging job to optimize those performance. But then with generative AIs, it gives kind of mimic the chain of thoughts from humans. It's not exactly a reasoning. They cannot exactly comprehend the language we have, but then it's because it has this sort of it can sort of understand language. It really closing the gaps for the silicon intelligence. So with that, so we will first so the the most pinnacle example of this is the humanoid robot we have right now. So if we think about AI, is that we give them a lot of data, so it's in a lot of array of tensors. You put weights and biases into those those tensors, and so that's how we form a neural net. And we would and right now, how they really make automate a humanoid robot is that they would do some demonstration with robots. So we would do a lot of samples with teleoperations. And
Sorry,
then,
Kwan, I think it's stuck on the silicon intelligence versus human intelligence.
okay,
Perhaps share again and see.
okay, okay.
Uh, yeah, no,
Now
now it's yeah,
we are on the slides with GIF,
autonomous
right?
robot. Yeah.
Yep, it's the GIF is moving, right? Okay.
No,
And
there's
then,
no GIF. It must be the GIFs that are making the difference, I think.
oh, really?
I think so.
Okay. I see. Right. But anyway, so we would use teleoperation to give the robots example to learn. That's the data, and then they would get the weights and biases in the neural net, so that from there we can train a visual language model as a robotics agent. So right now it's agentic control. You can just input voice and they output actions, because they can sort of take the voice and video as the input. They can output actions. And with this sort of new this kind of models, it can already do some simple household work, for example doing laundries, or even washing dishes, putting all those dishes into the dishwasher, etc., etc. So, what would be possible underwater, learning from all those tech from the land? So, I mean, there's a lot of reason why we don't have a very it will blossom in the ocean marine robotics scene, because there are a lot of challenges to build robots underwater, because it will have depth limits, and sometimes it would encounter extreme temperature. It's gonna be -2 Celsius degrees, and sometimes if you're working near the volcanoes, it would rise up a lot. So the change in temperature would also alter the mechanical parts and also the electronics. And also communication is an issue, and that is why it's so difficult to get a lot of things done underwater. We cannot uh, have Wi-Fi underwater, which is partially true. That is the ones that would not affect the ocean ocean animals and all those. But then communication is still big issues for robotic scenes. But then, however, I'm still optimistic about this because there's still a lot of technologies. For example, swarm robotics can also be implemented into the AUVs so that it could scan sort of synchronously across all the drones so that they could spread up the work, sped up the scanning work a little bit better. So if we could invest more into swarm of AUVs, it could definitely improve our speed into exploring the oceans. And also, robot could be made smarter. So the humanoid example is one of the example how LLM could make a robot kind of smarter. And also this is also another example of how people would implement it in defense space.
Oh, Kwan, we can't
So,
hear you. Oh no, now we can. Did you just take some water? Sorry.
so you mean a video?
Oh no, we can hear you now. It's okay. We couldn't hear
Oh,
you
okay,
for a
okay.
second.
Oh, okay. Then it's fine. But then I'll cut the clip. But basically, you see how the LLM could make the robot smarter. It could sort of
Yeah,
when
I
you
think
give
it's
them
I think it's the videos because we can't see because it's gone back to the communication is still a barrier slide.
Oh, really? Okay. So it's showing properly, yeah.
Robot could be smarter. Yep.
Uh, but anyways, let me describe what's inside the video. So it's basically the person would command the robot with voice command that shoot at a certain angles, and the robot could perform shooting in those two angles. And that's it's not exactly very agentic sort of robotic control, but then you can see how if we implement a tiny bit of an LLM model into the robots, it could make it we can give a more complex instruction other than, let's say, give them a set of arrays of coordinates to scan for. We can actually give some human language and let it do some sort of simple work. And then let me share the screen again because kind of trigger the videos. And then the robot can be made more accessible too. So going back
We
to the
can't we
web
can't
class,
we
I'll be
can't see the screen.
ah you cannot see right now, yeah.
No, it's just black. Perhaps skip over the slides that have a video.
Still cannot see, yeah.
No.
Okay. But this slide is working, yeah.
No, I'm unable to see it.
Oh, there's so much problem. What about now?
Yes, now is okay. User experience.
Is it on the making robots more accessible page?
Yes, now it is.
Oh,
Yeah.
okay, okay. I see, I see. So many problems, but stay with me, stay with me. Sorry. and then and then and then we can actually make it more accessible, as in like the expertise. So you don't have to be trained for a month to use a robot. We can actually take the example from the humanoids that they are actually using VR headsets to control the robots. It's still a very delicate, complex configurations that the humanoid robot have. It's bimanual, 2 arms, 2 grippers. It's still very difficult to control. But then with the VR technologies, they can easily control the robot and do some work on this. And some even would implement haptics control so that you can actually feel what's from the other ends of the robots. And because the console itself it's basically a goggle with a screen, you can also make different kind of visualizations to replace the 6 screens that we have on the RV console room. That's how I would describe it. But then control room. So from there, it's very possible with the technology we have right now can reduce the number of person to drive the RV, because basically 2 to really control the motion of the robots and the other 2 really trying to understand the environment. So I think with a lot of visual aids and trying to improve basically from the user experience sides, or even we are trying to process the camera outputs or sensor image, sensor data a little bit, we can make it more comprehensible for humans. And hence, we don't need that much of a screen to really understand what's happening around the robots. And then also 5G remote teleoperation is also possible. There's already some sort of implementation for agriculture monitoring by GC, that you can remotely put RV in some farm in Indonesia, and then you sort of monitor it from China. And that is very possible too. And also, what if if we could build something that is underwater research station that is fully automated? We can pick up samples. There's a station that we would like to invest more time and energy, that we would look into that areas. And there will be automations for picking up samples, sending maps, and there are some RV that is responsible for transporting some samples back to dock. And I think that is very possible too for our technology right now. And
It's
because
still on the making robot more accessible page, I think, because of the GIF.
ah okay, okay.
Do the further on slides have GIFs in them?
I don't think so. I don't think so. Yeah. Yeah.
We can't see the screen, so maybe just try share again.
What's happening? What about now?
No, unfortunately. Oh, no, yeah, it did. It popped up at the end. I think
Okay,
maybe
okay.
just have to wait a little bit.
Oh, wow.
User experience is what it's back on.
Yep. So
So
that was what. Yeah.
I think perhaps, yeah, make sure we've skipped to maybe the slides without GIFs, because I think that's where the issue is coming from.
Yeah, I don't have more gifts now. I'm so
Cool.
sorry about the
It's
technical
okay.
issues
It's
that we
okay.
have, but then yeah, there was what I was referring to. Like, if we can process the camera a little bit, let's say it's already implemented into some vessels already. It's called surrounding view. You can basically stitch 2 camera views into so that it could be made into a top view. So it's way easier for the drivers to dock the boat basically, and it could be made into a UI that is easier to read. So that those technology already existed on the land for a very long time. And it could certainly improve the performance of underwater robotics from that sense. And yeah, the research station automation that I mentioned. So it's basically like an automated smart port in Tianjin in China that they could just give cargoes on a cargo ship, and there's crane that unloads them and uh, store them in like a station, and the AGV would responsible for transporting them to those container trucks. So those automation already exists. If we could implement some of those into our underwater research, like it would be very helpful. There is like a little stations that everyone can get access to. You may have like a request for some water samples in some areas, and it's very possible that we can do this sort of automations and let the ROV automatically send them back to the dock, and improving performance of the ROVs. There's a lot of advanced manufacturing methods that can make it improve the form factor and dexterity of robots. So there's a lot of different kind of things can be brainstormed in within the marine robotics field, so that we could help with the research underwater. So is it showing properly now? Like you're seeing the
I
pole?
can see, we can see the streamlined subsea research automation.
Okay. Then let me share it again. So I think that's mostly the contents of my webinar. So
That's all
let's,
good. Well, perhaps
yeah.
we can go into the final poll, and then we can get people to ask some questions if they have any questions, which they can put in the chat now. So for the final poll, I will start it now. I think people should be able to see this. So it's a short answer. What instrument do you wish existed to help with your work? Or what do you think would be, I guess, really beneficial that Ho might not have touched on already? We'll give everyone a few minutes to answer, to have a bit of a think, because it'd be really great to see what people's responses are. Give everyone 30 more seconds. Ho maybe you can turn your video on now as well. All right, I've ended the poll. We had some answers, but because it's a short poll, we can't particularly share them, but we'll be able to talk about it later. But I think right now, if anyone's got any questions for Ho we can get the question session going.
Yeah, apologies. A lot of technical issues throughout the webinars, but then I'm very grateful you guys also stick uh, until the end of the webinars. But feel free to ask any
Absolutely.
questions. Yeah.
I have a question.
Yes.
At what stage is the development of the ROV? Like, at when do you think someone will be able to purchase one off the shelf?
Okay. Let me think. Let me think how to answer this. I would say we are working towards our first version of it, and we will have a big update soon. So I've talked a lot about the teleoperation on the robots. So I'm not gonna hide this. So I'm working on the teleoperation of this robot. We are developing. Sorry, I cannot English. But then I mean we are developing we already have a working teleoperation onto the robots, and then we will have a big update soon, very soon. So please follow our projects, and if you wish to know more about what's our progress is basically, yeah.
Awesome. Okay, well, if no one has any other questions, then we can end the webinar. But thank you all very much for your presentation. Oh wait, we've got a question. Sorry,
Oh, okay.
I need to give people more time. Um, what limitations do you see with this type of technology, and what major improvements do you anticipate in the future?
Um, sorry, I'm processing. Technology, I think I may want to clarify a little bit on the wordings, like what the limitation of this type of technology, but I right now assume it is you're referring to robotics underwater. So what are the
Yeah, I would say
limitations
that's,
at the
I
yeah.
think that's,
So the limitation right now is that how we can make it as if like an avatar underwater, that making them. So first of all, it's I've mentioned already the communication issues is pretty big because a lot of electromagnetic wave is not working underwater. So that's a very big thing. If we want to amp up like some of our acoustic wave, it affects the habitat, so it's not wise to do it. There's some other solutions to it, but there's no accessible way of doing this. So I think that's already itself a very big limitations. So as for the depth, we can actually work towards it because it's all about mechanical design and how we make the tolerance so that it could tolerate high depth and extreme temperature. That's not a new technology. But then for the communication part, it's a challenge.
yeah, that's interesting. And so in the near future, what kind of improvements do you see mainly?
So I can. Oh yeah, I did. But then I mean, if we can make it more automated or working towards RV agents that could work on a high autonomy on the water, it could sort of solve kind of the problem where it could work independently, trying to collect data and other stuff for you. But then I would say it would certainly improve the state of research or operation underwater. Just it's kind of the other way around. We don't need like a very high speed communication, but then because we can just give it a more complex commands and it can execute it so that we will get our job done. So that's the other routes I can think of.
Okay, great. Thank you so much, Ho Kwan. If anyone has any questions for Ho Kwan, I'm sure you can, yeah, follow through the QR code that he's put on the screen here, and through the details of the webinar. But yeah, thank you all very much for joining us today. And also please follow the ECOP program on LinkedIn as well, as we have other webinars coming up. And yeah, they're all in different time zones usually. So, but feel free to join whenever. Thank you all very much, and thank you, Ho Kwan.
Thank you. Thank you,
Thank
Jess.
you. See you, everyone.
Right, bye.